Hello friends, welcome to Tech Physics. So today we will see our fourth lecture on units and measurement, and today we are going to see accuracy, precision and errors of instruments and types of errors. But before going to that, let's see some important parts from last topic. So in last lecture we saw rules for arithmetic operations with significant figures. So there were two rules. The first one was for addition and subtraction, and the second one was rule for multiplication and division. So rule for addition and subtraction was when two or more numbers are added or subtracted, the final result should retain as many decimal places as there in the number with least decimal places. And the rule was same for multiplication and division, but there was one more thing, that is rounding off. So rounding off is when we get approximate result after the calculation, it contains some insignificant digits. This insignificant digits should be dropped by rounding off. For example, I have divided 3.96 by 2.1 and I got my answer as 1.885. But when I go with the rule for multiplication and division, it should have the same decimal place as same as that of the number with least decimal place. So therefore, I have to round it off to 1.9 because here the decimal is after one number. So here also the decimal should be after one number. So therefore I have rounded it off. But for rounding off there are certain rules, and that are, the first one is preceding digit is raised by 1 if the last insignificant digit from the right is more than 5. Second one is preceding digit remains same if the last insignificant digit from right is less than 5. And the third one is when the digit is exactly 5. So at that time we have to see the number which is in right direction from the last insignificant digit. So if it is even, then the preceding digit remains same, and if it is odd, then the preceding digit is raised by 1. So that was all we learned. And if you didn't see our last lecture on units and measurement, that is our third lecture, so you can see it here, and link is also in description, so you can also watch from there. So let us start with our today's lecture. So let's say we have a notebook having length 28.5 centimeters. So this is our notebook and it is having a length of 28.5 centimeter, that is given. But after measuring with a meter scale, I found its length to be 28.4 centimeter. Here previously given value is called as true value and the later measured value is called as measured value or observed value. So let us see accuracy. The accuracy of a measurement is a measure of how close the measured value is to the true value. So to know about accuracy, let us see an example. In first case, we have a true value as 28.5 centimeter and measured value as 28.4 centimeter. And in second case, I have a true value as 28.5 centimeter and measured value as 28.3 centimeter. So in these cases, we can say that the first measurement is more accurate than second one. Why? Because the 28.5 and 28.4 are closer and 28.5 and 28.3 is less closer than the first one. Therefore, we can say that the accuracy of the first measurement is better than the second one. So let us go to the new one, that is precision. Precision tell us to what resolution or limit the quantity is measured. So for that, let us take an example. Let's suppose that I am measuring the thickness of a book using meter scale and vernier caliper. So after that, we can say that second measurement is more precise than first one. That is, precision of measurement done by the vernier caliper is better than the measurement done by the meter scale. So let us go to the third topic, that is error. The result of every measurement by any measuring instrument contains some uncertainty. This uncertainty is called nothing but error. Mathematically, we can say that the error is magnitude of difference between true value and measured value. So let us take an example. Let us say I have a true value as 28.5 centimeter and measured value is 28.4 centimeter. So in this case, error will be magnitude of 28.5 minus 28.4, that is 0.1 centimeter. So in this given example, the error will be 0.1 centimeter. In journal, we can broadly classify errors as systematic errors and random errors. So let us see systematic errors. The systematic errors are those errors that tend to be in one direction, either positive or negative. The source of systematic errors are instrumental errors, imperfection in experimental technique or procedure, and personal errors. So let us see them one by one. Instrumental errors. They arise from the errors due to the imperfect design or calibration of the measuring instrument, zero error in the measuring instrument, etc. For example, error occurs when the zero of the vernier scale doesn't coincide with the zero of main scale in vernier caliper and micrometer screw gauge. Imperfection in experimental technique or procedure. So it is very simple. They arise from the imperfection in experimental technique or procedure. For example, to determine the temperature of body, when we keep the thermometer on the armpit, it gives temperature lower than actual temperature of our body. Personal errors. So they arise due to an individual's bias, lack of knowledge and carelessness while taking readings. For example, when we take readings of analog voltmeter through different angles, instead of taking it straight, we are introducing an error, and that is the error due to the parallax. Random errors. So these are second type of errors. The random error is an error that occurs irregularly and hence it is random with respect to the sign and size. This type of error arises due to the unpredictable fluctuations in the experimental conditions. For example, when same person repeats an experiment, he may not get same readings. So this happened due to the random errors. So let us take the small revision of whatever we have done till now. Accuracy. The accuracy of a measurement is a measure of how close the measured value is to the true value. For example, if true value is 28.5 centimeter and measured value is 28.4 centimeter, in first case and in second case, the true value is 28.5 centimeter and measured value is 28.3 centimeter. So we can say that the first measurement is more accurate than the second one, that is, accuracy of the first measurement is better than the second one. Precision. Precision tells us to what resolution or limit the quantity is measured, that is, if I take a reading from meter scale and vernier caliper, then the reading taken from the vernier caliper will be more precise. Error. The result of every measurement by any measuring instrument contains some uncertainty. This uncertainty is called error. Mathematically, error can be written as magnitude of difference between true value and measured value. For example, if I have true value as 28.5 centimeter and measured value or observed value as 28.4 centimeter, then error will be magnitude of difference between 28.5 and 28.4, which is nothing but 0.1 centimeter. So in this case, error will be 0.1 centimeter. There are two types of errors, systematic errors and random errors. Systematic errors occurs due to the sources like instrumental errors, imperfection in experimental technique or procedure, and personal errors. And random errors are the errors that occurs randomly or irregularly. So this type of error arise due to the unpredictable fluctuations in the experimental conditions. For example, when same person repeats an experiment, he may not get same readings. So finally, this is an end, and if you like this, please like my video, share my video and subscribe to my channel. Thank you.